Good morning students. Today we will be discussing about de Broglie's hypothesis of matter waves. Last class we have discussed about wave particle duality. In wave particle duality we proved wave is having particle nature and wave is having wave nature. Wave is having particle nature is proved by Einstein photoelectric effect, Planck's radiation formula, Neil Bohr atomic model, Compton effect, black body radiation. From this we have proved that wave is having particle nature. Next, wave is having wave nature. It is proved by interference and diffraction experiments. But till now we have not proved that particle exhibiting dual nature. This particle exhibiting dual nature is first time proved by de Broglie. So here de Broglie has not done any experiment. He is the theoretical physicist. Theoretically, he proved that particle exhibits dual nature. He is also Nobel Prize winner. Now, here in 1924, Louis de Broglie made a suggestion. He made a suggestion that like waves, particles also exhibits dual nature. Particles means nothing but matter. Matter also exhibits dual nature. Particles means electrons, protons, neutrons, and we are also particles. So we should prove that these exhibits wave properties. So here de Broglie's suggestions he made theoretically he has explained, means he made some suggestions. Based on these suggestions he proved that matter exhibits wave nature. So first suggestion is the entire universe consists of matter and radiation. Means entire universe is filled with particles and radiations. Next, second one is nature loves symmetry. Means nature always want to be symmetrical. Symmetrical means mirror image should be the same. The image should be the same. Means if radiation has dual nature, then matter also should have dual nature. Next, see here, next third one is the periodicity of electron in Bohr's atomic model. Means if I take periodicity of electron will be moving like a wave it will be moving like a wave. So maybe in the intermediate you have written MVR is equal to NH by 2 pi. So that suggests that electron is moving like a wave. Next, principle of least action in mechanics is similarly equal to the principle of least time in optics. Mechanics is related to particles, optics is related to wave. So these two coincide, principle of least action in mechanics and principle of least time in optics coincides. Means it says that particle is exhibiting wave nature. Okay, now question is which particle exhibits wave nature? When the particle is at rest or when the particle is moving? So see here, when the particle is at rest it behaves like a particle only, but when the particle is moving it behaves like a wave. So a moving particle is always associated with a wave which is known as matter wave. For example, if you are sitting in the class, when the lecturer is present, if you are sitting in the class, he will behave like a particle because you are not moving. But in the break period, what you people will do? You will be roaming. You will be moving. So, when you are moving, you will be moving like a wave. Means I cannot give position. I cannot give location of you. So, that we call it as matter wave. A moving particle is always associated with a wave. Moving particle always have wave nature, that we call it as matter wave. Now we'll try to derive wavelength for matter waves. So de Broglie has given expression for wavelength of matter waves. What are matter waves? Particles, nothing but particles. But which particles? Moving particles. So these moving particles exhibits wave nature, that we call it as matter wave. So if moving particle is having wave nature, it should have wavelength because it is behaving like a wave. So de Broglie has calculated wavelength for a moving particle. So how to calculate this? So see here, based on Planck's theory of radiation, energy of photon. What is the energy of the photon? E is equal to h nu. H means Planck's constant. Its value is 6.625 into 10 power minus 34 joule into second. Nu is called as frequency. Frequency can be written in terms of lambda. So I can write it as hc by lambda. C means velocity of light. Velocity of light, that is 3 into 10 power 8 meters per second. Lambda is the wavelength. This is equation number 1. Next, according to Einstein's mass energy equivalence, we know Einstein's mass energy equivalence is E is equal to mc square. E is equal to mc square. So this is also energy. This is also energy. So I can equate these two equations. So if I equate these two equations, I will get hc by lambda is equal to mc square. From this, lambda is equal to h by mc, which is equal to h by p. P means nothing but momentum. Momentum is equal to mass into velocity. But what is here C? Velocity of light means only photons can travel with speed of light. This is the expression de Broglie's wavelength only for photons. This is the de Broglie's wavelength only for photons. Okay. Now see here, de Broglie, see here, this is the equation for only for photons. But if I take other particles other than photons, means for example if I take electrons, neutrons, protons, what will be the de Broglie's wavelength? So see here, if I consider any other particle which is having mass m, moving with velocity v, then what will be the de Broglie's wavelength? Lambda is equal to h by mv, which is equal to h by p. H by p. This is called as de Broglie's wavelength. De Broglie's wavelength for matter waves for all other particles except photons. For photons it is lambda is equal to h by mc, because photons can travel with speed of light. But for all other particles, lambda is equal to h by mv, which is equal to h by p. So this is the de Broglie's wavelength for all other particles. Okay. Now if we want to write de Broglie's wavelength in terms of kinetic energy, then how to write? We know kinetic energy E is equal to half mv square. So if I do this, E is equal to half mv square, I know that. So here if we see this half mv, here I will multiply and divide with m. So I will get it as m square v square is p square by 2m. From this I can write p is equal to square root of 2me. What is the de Broglie's wavelength? We know de Broglie's wavelength lambda is equal to h by p. De Broglie's wavelength lambda is equal to h by p. P value if I substitute, I will get lambda is equal to h by square root of 2me. So this is also de Broglie's wavelength for all particles. But if kinetic energy is given, this is the formula to calculate de Broglie's wavelength if kinetic energy is given. So de Broglie's wavelength for photons is lambda is equal to h by mc. De Broglie's wavelength for all other particles is lambda is equal to h by mv. For if kinetic energy is given, lambda is equal to h by square root of 2me. So this is about de Broglie's wavelength of matter waves. Thank you.